Right, so I'm going to live solve questions 1 to 5 from the 20T3 practice exam. I haven't seen these questions before, so you get to see a problem-solving process and how I approach the unseen questions, what I think about first, and how I break things down, and hopefully it'll be fairly useful. Alright, so we have to first make a folder, 20T3 final, and run the command. Cool. And refresh. And then we get everything and a question. Alright, let's read what it says. We have been given the .s file that reads one number and prints, and we need to make it equivalent to this C program. Okay, so this C program is just going to scan two numbers and then return or print x plus y times x minus y. Alright, cool. So, oh, it's here. Right, so we can open up both side by side then, which should be useful for the exam. Alright, so the first thing we need to do is scan two numbers. Alright, cool, we've got a scan here. And if I just go and scan again twice, we're going to then clobber over what we just had in v0, because remember, when we syscall to scan, v0 is equal to the scanner number. So we're going to have to move this to say t0. And so t0 will store that x. Like t0 is equal to x. Similarly, after we scan here, we can say that t1 is equal to v0. T1 is equal to our y. Because after we do our syscall 5, that v0 is going to be what that integer was that we scanned in. Okay, cool. Then we just have to evaluate what these two things are. So we can say add, and we can say, let's just store that in t. Two things individually. And then what we actually want is the multiplication of them. So I can say T4 is T2 and T3. Okay, and then when we print, we put our %d, our integer, as our A0. So I'm going to move that into T4. And this should work. Cool. Awesome. Question 1 should be fairly simple. Alright, question 2. So we have to add code to this function. So that given a unsigned int with 32 bits, it returns 1 if and only if the least bit is equal to the most significant bit. Okay. So if you look at this example here, 0 is the same as 0, so it should return 1. Yep. In here, 0 is different to 1, so it should return 0. Okay, cool. So let's break this question down. Let's just use a let's use an 8-bit number. Let's say our number is 000000001. What we're going to need is some way to get this bit out and some way to get that bit out. And then let's just say this is equal to A, this is equal to B, and then is A equal to B. So how can we get these two different bits out of the number? Okay, so to get this bit, or to get any bit specifically, we're going to use like the ampersand operator. Because what happens when you use ampersand, let's just say I have, let's say I AND this with a number 1. So this is like, x is some number here, y is some number here. If I do x and y, so if I AND these together, the resulting number is going to be the bitwise AND of each of them. So 0 and 0 is 0, 0 and 0 is 0, so these will become zeros. Now 1 and 1 becomes 1. So in general, if we AND two bits together, the resulting bit is only 1, if and only if both of them are 0. Both of them are 1, sorry. So that means that we can then test for what the value of this last bit here is in our random number. So if this was like some new string here of bits, let's say this was like this. If I still AND it with the number 1, we're only going to get that last bit. Similarly, if I AND x with a different number, let's say I AND x with this, then all of these zeros here will mean that all of this becomes 0, and then we're just going to get whatever the bit is at the most significant, which would be 1 in this case, because 1 and 1 is 1. If this was a 0, then this would also be a 0. So that's a really easy way we can get the bits at certain positions. Okay, so say this is a 1 here, and then we do obtain the 1 there. Now, how do we actually compare this to, say, the one that was down here? So when I did, let's see what I wanted to say. Actually, let's just copy paste this twice. We'll make this one a bit smaller. Make this one over here. So we've got these two numbers, and we need to get the first bit out, and we need to get the last bit out. Okay, so let's make this one a 0, and we'll make this one a 1. And so when we AND them, we get this. Okay, we need to see if these two are equal. Now this number here, it's really just a really big number. This is like 2 to the 0 plus 2 to the 1 plus 2 to the 0 plus 2. No, sorry. This is 0 times 0 times 2 to the 0 plus 0 times 2 to the 1. This number here has this is equal to 2 to the 7, which is 128, I believe. And then this will just be here at 2 to the 0, this number. But how do we actually compare these two? Like we want to compare these two bits here. We don't really care what like these extra zeros. Let's delete this. So what we might want to do on this question is move this one bit down all the way to the end. So we know how many positions or how many zeros are going to be here. We know there's going to be 7 of them because there were 7 bits that we didn't care about. So what we can do, if we just say this is equal to C, we can shift C 7 positions to the right. So that means this 1 here is going to move 7 to the right, and then we would just get its 1 here. And then the computer will automatically fill the rest of these in with zeros. So now, once we've shifted this bit all the way to the right, we can then directly compare it with this 1 here, because they both would be the same number if, if this bit was indeed the same here. When we shift it to the right, then these two would be the same number. So let's just try and implement that in our code then. All right, let's open question 2. So, qn12345 type, and we can say x, not x, what do we call it in our paint? Oh, I called it y. Let's just call this one mask 1, we can call this one mask 2. So, mask 1 is equal to something, qn132 type, mask 2 is equal to something. Now, what are these masks actually equal to? Okay, well, in my example, I was just using 8 bits. So these would be represented with 2 hexadecimal numbers. But in the question, we're given a qn132. So that means it's 32 bits. So we're going to need 8 hexadecimal numbers because there's 4 bytes. So the most important thing is that we're going to have 32 bits. And so we need to have this 1000 at the beginning, right? And then we're going to have 32 minus 4, which is 28 zeros. Now that means there's going to be 7 blocks of these zeros. 0, 0, 0, 0. This happens 7 times. And so the way we represent 0, 0, 0, 0 in hexadecimal, this is just equal to 0. And the way we represent this 1000 in base 2, this is equal to 8 in base 16. So what we want to do is then say 8, 0x8, 0, 0, 0, 0, 0, 0. And then for the other one, it's going to be 28 zeros. And then we would have the 0001 at the end, because we need to have this 001, so we get the mask of the last one. Okay, so that would be just the 000000, and then we need that 1. I think I didn't give enough. So there should be 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7. Oh wait, no, I think I did enough the right time. There should be, wait, let's just write it out again. 1, 2, 3, 4, 5, 6, 7. And there should be 1, 2, 3, 4, 5, 6, 7. There we go. Because we need 7 blocks of the zeros, because 7 times 4 is 28, to give us 28 zeros here. And then we have the 8, or we have the 1. Depending on if we want, this would be like the 1000 for the 8, or this would be like the 0001 for the 1. Okay. So now we want to AND these two together, because when we AND, if we get like C1 here and C2 here, we would then get that most significant bit in the most significant position, or if we do the X and M2, we'll get the least significant bit in that last position. So we can do that. We can say uint32t C1 is equal to mask 1 and value. And I'm just going to copy this and say C2 is equal to this and that. Okay. Let's remove some of this. Now with C2, we didn't really have to do anything because the bit is in that last position. But C1, in our example here, we had to shift it 7 bits to the right because we wanted to be able to have that in that last position. So if this was an 8-bit number, we shift it 7, but since the question we're using 32-bit numbers, we're gonna have to shift that 31 to the right. So with that C1, we're gonna say C1 equals C1 shifted 31 bits to the right. So now, C1, once it's shifted to the right, this 1 bit is now actually here. And now, if C1 is equal to C2, then we can return 1. Else, we just return 0. And let's go to the auto test. Perfect. All right, let's go to question 3. So it says, write a C program which takes in 2 names of environment variables as arguments. Okay. So it should print 1 if both argument variables are set to a similar integer value. Otherwise, they should print a 0. Otherwise, and we say that similar if they differ by strictly less than 10. An unset environment variable should assume to have value 42. The shell command export sets an environment value to a value. Okay. Interesting. I haven't touched environment variables at all, so this will be a good thing to see how I would attack this question. Environment variables. Okay. Is there a man environment? Okay, there is. What about man 3 environment? No, there is not a man 3. This is just the Linux config. Is there man 2? Okay, there is man. There is the environ. which is just the char array, string array. So how do we read the environment variables? Okay. Let's go to the C reference. Is there anything in here that can help us? Environ. No. Okay. Oh, I can't remember the function. Oh, I think there was something called like get environ or set environ. Or set env. Ah, there was man3 get env as well. So get env is the one we're going to want to use in this question. Okay. So it pays to remember what the function names are called. Okay. So we're gonna have to make this file. Int main. All right. So it takes in 2 parameters. So we're gonna need arg int argc char star argv. Okay. Then we do this. So char star var1 is equal to argv of 1. Char star var2 is equal to argv of 2. Because in our argv array, we have our program name, does that, and then you have your what's it called? Like your arguments that you give. So this one would be like var1, var2, and so these are indexed from 0, 1, 2. So that means index 1 and 2 are going to be our 2 strings. So using the getenv, what's it called? Getenv function, sorry. And this comes from the stdlib library. So hash include stdlib.h. We're going to have to do char star val1 is equal to getenv of var1. And char star val2 is equal to getenv var2. So these return a character pointer to the value. So it just returns the corresponding value string. Okay. Oops. Here. So we want to return if they're similar. So if they differ by strictly less than 10. So mathematically, this means that like a minus b is less than 10. So we can then say absolute value, which library does this come from? This just comes from stdlib2. Okay, now the problem here is that we have to convert from the character pointer from the string to integers. So how can we do that? Let's just use printf here. Let's see what these things look like. Let's just do like %s val1. And should I do it in here? We should just put this here. This. Does this work? Okay, unused variable doesn't really matter to me. %s. Because it should be a %s. There we go. Okay, perfect. So it is just this, the number, but it's stringified. So what we really want to do then is just cast these, well, not cast, so we want to convert them from strings to ints, so we can just use a to I. So we can say like int a is equal to a toy val1, and int b is equal to a toy val2. And then, oh, I'll just keep it here. You can say if abs of a minus b is less than 10, then we want to print what? If a is strictly less than 10, similar, so we print 1. Print 1. Print 1. Wait, is it print or return? Print. Else print f0. Put the print f in there. Okay, there's one important thing we're missing. If it doesn't exist, it should be 42. Okay, so how do we check this? So clear man get n. So if there is no match, it will return null. Okay, if val1 is equal to null, else do something. Okay, so what we can do, we can say if it's null, a is 42, else a is this. And then we can do the exact same thing, but for b. So if the string is null, then we just set p is 42. Otherwise, we convert the string to integer, and this should work. So let's auto test this. Because I'm missing stereo. Thank you. Perfect. Okay. So the man pages are really helpful in that question because, well, I didn't remember the function name quite at the first glance of the question. By just chucking things into the man, I could see like what I want. Like keep trying different function names. Okay, next question. We're being given. So we have another translation one. So we need to make it equivalent to this C program. Okay. Question 4C, question 4.S. Okay. Move this here, move this here. All right. So let's move this down a bit. So int low is 0, int high is 100. So let's load this in. Let's say t0 is 0, li t1 is 100. Okay. So that means that t0 is low and that t1 is high. So let's not forget that. All right, now we see we have a while loop. So whenever you have a loop, we want the 5 labels. So we want loop init, loop condition, loop step, loop body, loop end. The step should go after body. Yep. Now you don't usually need all 5 of these labels, but I find having all 5 of them really helps, especially for debugging. Okay. I guess these would make more sense to be under init, maybe not, doesn't really matter. Okay, so the condition, while low is less than high, so we're going to get this condition and then take the negation of this, so that would be like greater than or equal to. So we're going to use BGE, low, T0, high, and end. Because when it's greater than or equal to, so when the negation of this is true, then we want to jump to the end. So you just take whatever this is, you flip the sign, and then you use that as your condition. Okay, and let's just put the step in straight away so we don't forget. We want to jump just back to the top. Okay, now it's this body we're interested in. So you need to scan f. Okay, we're scanning f1, we're scanning f a integer. Okay, let's just copy the scanf code they've given us and put it here. And we can move T2 can be this. So we can say T2 is equal to X. Because after you do your syscall, your V0 will contain your value scanned in. So I'm just going to move that to X. I guess we don't need to because there's not much going on with V0 afterwards anyway. But it's better practice, I guess. Okay, so now we need to say low is equal to low plus X. So add T0 is low. It's equal to T0 plus T2. Okay. Now we need to add something to high. We say add. Oh no, we're not using add. We're using sub. T1 is equal to what? T1 minus X. And X is equal to T2. Okay. And there's nothing else in this loop. Awesome. Now at the bottom, we're printing something. We're printing what? We're printing low minus high. So I'm going to do sub. Let's just put this into T3. We haven't used T3. And that's equal to T0 minus T1. Cool. And we need to move this into A0 so it knows to print that as the integer there. And then this prints the new line character, and then we're done. Cool. Let's put that in here. Awesome. Let's go to question 5. All right, we need to copy a file without some bytes at the end of a file. So, okay, write a C program, which takes in 3 arguments. Its first argument will be an n, the number of bytes not to be included. The second argument will be the name of an existing file. The third argument will be the name of the file to be created. Okay, so we're like copying from here to here, except these bytes. I think that makes sense to me. If the existing file has n bytes or less, the new file should be created with 0 bytes. This is like an edge case here. Okay, I think that makes sense to me. Let's read with this. Okay, so I think this is just the only edge case here. If it has n bytes or less, we just write nothing. Okay, so let's open Q5. Do we not have a file? I guess we don't, so we can just make one. I don't understand why they don't just make the files for us. I guess they want me to write something here. We need int argv char star argv. Should be argc arg count arg v for vector. Okay, so we have a file here and we have a file here. So we can say char star file name file, right? Right. Read name, let's call it that, is argv1 and char, is it v1? No, it's v2. Write name equals argv of 3. And then we can say int n is equal to a to I argv of 1, because we need to take the n out of there and then turn it into int. Okay. So we need to open both of the files. So we can say file star f read equals we should file read. No, let's call this. Or let's call fd1. F open. Read name, and we're reading. File star fd2 is just f open. Write name, and we're writing. I think it's R and W. how can we check this? We can just go man fopen, and we'll get the library we need to include. Go down here, and then W is for writing and R is for reading. Perfect. And then at the end we need to fclose fd1, and we need to fclose fd2. Okay. Now, how do we actually know the position in the file that we want to stop? So I think there is something called ftell. Yes, so ftell is going to obtain the current value of the file position indicator pointed to by like the cursor. So if we think of a file that has, just say it has some bytes in it, initially your file cursor is going to be pointing to the first one, and then if you ftell is going to return the position that your cursor is pointing to. So if I have ftell over here, if I have my file cursor here, then ftell is going to get me the like the position that it's at. So this is going to be really useful. If you didn't know what that function was, you'd probably first think of like fseek, which is really good because ftell comes up when you search fseek. So because they're part of like the same family, fseek is going to move that file cursor, and then ftell is just going to get back like the position of the cursor. So yes, so what we need to do, if the existing file has n bytes or less, a new file should be created but with 0 bytes. What we can actually do here, we can make a while loop and say like while the like can I do this? While like the cursor is less than position n, do this, and what we want to do, we would want to like read the byte, write the byte. And so while this like cursor, that file cursor is less than the nth position, wait, is it nth position? Oh no, it's number of bytes not to be included, like some stop position. You keep reading and writing, and that cursor keeps moving to the right, and then once it hits some stop position, then we're going to want to stop doing that. So how do we figure out what this stop position is? It's going to be n bytes from the back of the file. So what we can do, we can say fseek, we can move the fd1, man fseek. Now we're going to want to give it the file pointer, we want to give it some offset, and we want to give it some whence. So we can say n, and we want it from the back, seek end. Now what this is going to do is going to be n bytes after seek end, which isn't what we want. We wanted n bytes before. Okay. So like what that would do is say we have like your file, it's got like x bits or x bytes. Seek end would be at the end. So if we have like n is equal to 2, then we're going to move it 1 and 2, and so we would be getting the position here. So it's like we want to stop whenever we hit this. So we want to fseek and then like figure out which is this position, and then we want to stop if we ever like hit that position. Okay. Fseek, seek end. I think that makes sense to me. Okay, but let's think back to our question. It says if the existing file has n bytes or less, then we have to do something. So what would we do here? Because if there were not n bytes in the file, then fseek is going to return an error. So let's go down to our return. Otherwise, -1 is returned. Okay, so we can say int error is equal to this. if error is equal to -1, then what do we have to do? Oop. You just create the file, and then that's it. We've created the file here, and then we do nothing, so we should probably close them and return. Okay. Now, if there was no error, then we need to figure out what this position was. So that's where ftel is going to come in. Man3 ftel. So int end is going to be ftel fd1. Yep. Because we've moved our file cursor to that nth byte, or like end from the back. And then so our end here is going to be that position. So then we can say while is less than end. And so we can just chuck in ftel here and say while it's less than end, assuming that we did move it back to the front. Seek set. Yes. So we want to figure out where the end position is, then just move it back to the front. Okay, so we need to read a byte. So we're going to go int c is equal to what am I doing? Fget c, fd1, and then we just want to fput c in fd2. Okay. Were there any issues potentially with EOF? Like an NB0? What would happen with n equals 0? I don't think we can get n equals 0. Alright, let's just auto test this and see if it works. No, we have a error because I haven't done my hash includes, obviously. Alright, so this one's going to be stdlib. I think the rest of them should be fine. No. Return 0. Okay. Now what? Fput c, because fput c comes from obviously we need to actually figure out what the character is that we are putting here. That would make sense. Oh, okay, lots of errors. These are good. Okay. Okay, let's read fput c. Oh, because C comes first. See. I had a feeling it might be that. Okay. All the tests pass, which is usually a good sign. But can we double check that our program works when n equals 0 though? Actually, what happens if n is negative? Oh, it's always a non-negative integer. Okay. What happens if n is equal to 0? How do we actually write this thing? Because when n equals to 0, then we can get errors with like EOF. Okay, let's just make this echo file. And then let's call this with n equals 0. Okay. And these should be the same thing. Perfect, and they are. All right, so that is questions 1 to 5 done from the 20T3. If I made any mistakes, please let me know. If you found it helpful, please also let me know. Thank you.